Good afternoon, all.
Good afternoon, ma'am.
Good afternoon. We will be beginning with the next unit, that is linked list, last but one unit. Okay. Um, so, uh, Before I begin with the chapter or introduce you to what is called as linked list, uh, let us first discuss from your end. Okay, I want you to comment on the things that I'm asking right now. What all are the disadvantages of arrays? See, till now we have used for any kind of data structure implementation, we have used what is called as arrays, correct? We have done array implementation of stack, we have done array implementation of queue, priority queue, we have done array implementation of circular queue, correct? So what did you find that arrays are not good? In some ways, arrays are good, definitely. But what are the things that you feel that this has to be there? This convenience is not available in arrays. Something like that. What you felt about it? Can you comment?
Wastage of memory, ma'am.
Wastage of memory. Can you elaborate?
Ma'am, like we don't array means we have to have a continuous memory, ma'am. Like
Okay.
we cannot have um, like if we allocate 100 and if we only use 5 of the array, the rest of the memory will be wasted, ma'am.
Correct. So one point that Pranav has commented, that we will have wastage of memory. Suppose that we have initialized or we have requested from the compiler about 1,000 spaces for the integers, but we have utilized only 100 out of it. So 900 memory locations are wasted. Okay, well taken, Pranav. But I want to add to your comment. Nowadays, memory is not at all our concern. You also know that in a small chip, I will get 1 terabyte, 100 terabyte of memory. Okay, so nowadays, memory is not a worry at all. You will be thrown with the memory. Okay, so you can utilize in any ways you want. In fact, nowadays, memory is not a problem. Okay, but what you have commented is correct, 100% correct. Any other comments? So
Ma'am, the
one is memory
staticness of
wastage.
array.
Yes, Yogesh, please come again.
Ma'am, the space is static. If we have declared 100, then we can't use 101.
Correct, correct. So again, it is memory related. So you cannot initialize less, sorry, you cannot declare less and initialize more elements. So arrays are static, correct? Any other comments? Two things we have got. Okay, Rameshri has commented in the chat, time consumption. Can you elaborate, Ramya, on this? So two things told by, okay, uh, Praveen has commented unsizable as and when required. Yes, definitely. So Ramya, can you elaborate on the thing that you have written? Time consumption. In what way time consumption is there with reference to arrays? Any other person can comment on it? Or any other points you felt that arrays are not good? Okay, no other comments? So let me elaborate on the point that Ramya has mentioned. She mentioned that there is a problem with the time consumption. When and where the time consumption problem will come? You have seen this when you are implementing priority queue. Okay, whenever you try to insert a new element, every time before you place the element in a proper position, you are shifting so many elements. Okay, there is a lot of time wasted in doing the shifting of the elements than actual insertion. This is a major drawback of an array. When you want to have arrangement of the elements in the array, arrangement of elements, that arrangement will lead to a lot of memory transformations. Okay, imagine you are trying to insert a new element at a 50th position, and there are 150 elements available already. In that 150 elements, out of that 50th element you want to replace with a new value, or you want to insert a new value at 50th position. So you just imagine there has to be 101 shiftings done. Okay, this becomes much clumsier when I compare that with the actual insertion. This is a major drawback of arrays. So very good points commented by all of you. Let me just read out. I think Praveen has commented something. Time consumption may not be a problem in a way, since arrays does not contain in access in only one direction, otherwise it provides random access. May I know, Praveen, what is the meaning of your comment? Can you elaborate?
Um,
Go ahead. Go ahead.
like in implementation of other arrays, ma'am.
Hmm?
In stacks, you can see, ma'am, it is only from the top we can access the elements, ma'am.
Hmm?
But in if we are using arrays, ma'am, normal arrays, we
Hmm?
can very well go with the 150th element or with the 151st element, ma'am, as and when required, ma'am. So it provides random access, ma'am. It doesn't constrain us to using only one direction of access.
Correct.
So, ma'am.
Correct. That is an advantage of array you are speaking. Okay. But I'm asking
Yeah, ma'am.
about disadvantage of arrays.
Yes, yes, ma'am.
Okay. Yeah. So with this background, let us begin with what is called as, just 1 minute. Ashita has commented, number of elements to be inserted should be known before. Correct, you are right. You are right, Ashita. Okay, according to this discussion, we have these many number of drawbacks. Of course, arrays are having ample number of advantages, definitely. But always human being is very greedy. Okay, if I have 50 good points and I have two non-good points, I will always point to these non-good points. Okay, so non-good points have to be rectified. How that rectification is done? That rectification can be done by using what is called as linked list. Okay, how this linked list is actually implemented? Um, okay, every element, whenever you insert or delete, every element is treated not as an element but treated as one big entity. That big entity is dealt in such a manner that it has majorly two parts in it. Okay, let me repeat what I am telling. Every element in the normal array implementation is treated as an element. Okay, but in the linked list perspective, every element is not treated as a simple element, but it is treated as an entity which contains majorly two parts in it. The first part talks about what is the actual element or the information part, and the other part contains this currently inserted element has to be linked where? It has to be linked where? Okay, this linking is nothing but the address of the next element or the address of the previous element. If it is getting linked, you just have to imagine this with the bogies of a train. Bogies of a train. In the middle, if I want to insert a new bogie, what you are supposed to do? If you want to insert a new bogie at the center of the train, what you are supposed to do? Can you comment on it quickly? If you want to insert a new bogie at the center of the currently existing train, what you are supposed to do for that? This is a general question. Okay. Yes. Disconnect the middle bogie and then add. And when you are adding, how do you add it? You will add in a manner that the new bogey that is getting added has to be inserted at the middle, and in such a manner that the new bogey has to be connected to the middle -1 as well as middle +1. And then this becomes the new middle. Are you getting this? So every element that is getting inserted will know or will have to know what is called as to whom I have to get connected next, to whom I have to get connected before. This is called as the address part or the link part. Okay, so every element in a linked list is not merely an element, but it is an entity containing two very important parts. One part is the information part and the other part is the address part, to which this particular link to which this particular entity getting connected. Okay, before I start with linked list, you have missed out one more very important drawback of array. Okay, let me just cover up and then let me begin with that. See, when you have created an array, when you have declared an array, how the array positions or the locations are allocated in the memory. Can you comment on this? If I have declared an array of size 100 of type integer, how many bytes have to be allocated? How many bytes have to be allocated? If I have declared an array of size 100 of type integer, how many bytes gets allocated? Correct? 200. Okay. Now these 200 bytes have to be sequentially available. Shreyas, you are right. It has to be sequentially available, or I'll call it as contiguous memory location. Okay, that contiguous memory allocation is part and parcel of any array that you take, static array that I am talking about. That is one more disadvantage of an array. Imagine I have reached a situation where I have asked for 2 lakh memory locations at a time. 2 lakh elements or 1 lakh elements I have to insert of type integer. So I require 2 lakh bytes, and I may not have 2 lakh bytes sequentially available. This is one more disadvantage of arrays. This can be overruled. This can be overruled where non-contiguous memory locations are just thrown to you as and when you ask for. That is also made available by what is called as linked list. So linked list plays a very important role in having non-sequential memory locations allocated for different elements. As well, it talks about dynamically allocating the memory. So do you remember, please, before I get into this linked list, do you remember the various dynamic memory location functions that we have discussed? Can you quickly comment what are the functions that we have dealt with? I'll wait for your comments. Dynamic memory allocation, deallocation functions. Can you comment on it? Correct, all of you are right. Malloc, calloc, realloc, free. 100% correct. So these are the functions that are available for me in C. Okay, so using these things together, I'll come up with a new data structure that is called as dynamic linear data structure. I'll not call it as non-linear. What is linear? What is non-linear? I have discussed it before only. Okay. I have a special linear data structure, which is dynamic data structure, and allocating non-contiguous memory locations, that is called as linked list. Okay, with this background, let us go ahead with what is called as linked list chapter. Okay, all of you are awake, guys? I hope so. Yeah, since you are answering to my questions, you are all awake. Thank you all for that. So let's go ahead. Whether the font is okay, whether the screen is clear, please comment quickly. Yes, thank you. Now, so what is a linked list? Can anybody comment on what is the discussion done till now? What is a linked list? Jaldi. Guys, you have to be quick and active for this chapter. Okay, I just get lot of goosebumps when I take this chapter. I will get a lot of interest in teaching this. It has to be a physical class. Okay, Okay, let me check what is the comment that is made. Dynamic array with address for linking to the next element. Okay, well and good. Inserting element in between a series of elements. Okay, well and good. Any other comment which is very simple to understand? Simple way of telling what is a linked list. Array having both data and address parts. I'll not call it as array, Aditi. It is not an array. Okay, linking each element next to each other. I think all of you are explaining how linked list works, but I don't want how linked list works. Yes, you are right, Anushka. Linked list is a linear data structure, linear dynamic data structure. Okay, in simple terms, I'll call linked list as a linear dynamic data structure. Okay, let me just go ahead with this. Like arrays, linked list is also a linear data structure. But what is differing in this, I do not have contiguous locations as I have in case of arrays. Okay. One more very important difference is every time a new element getting inserted, that new element is associated with what is called as a pointer, because whenever address comes, there has to be pointer. Okay. So in simple terms, linked list is a linear dynamic data structure. Okay with it? I hope this is clear for you. Okay. Next. So when we have arrays already, why do we require one more new data structure to confuse ourselves? Okay, I think probably we have discussed, you have given wonderful points about this. So taking into those things in our mind, we will just go ahead. All the things that you have talked about, those things only are listed. Okay, this is an example. If I want to insert 1020, so I need to shift 1050, 2000, 2040. We have done this in priority queue already. Okay, the same thing I have explained. Now, what are the advantages of linked list over arrays? First of all, it is of dynamic size, okay, and there is easiness in insertion and deletion as compared to arrays. Okay, what is the disadvantage? Random access. Praveen had pointed out very nice point about this. Arrays are more preferred in most of the data structures because it talks about random accessing. See, I'll not bother to access 50th element being in 0th element position. Okay, you can call upon whichever element that you want at any point in time. That's why random access is allowed in arrays, which is not so much very well established in linked list. Okay, so random access is the most important advantage of arrays over linked list. Then extra memory space for every time you insert a new element has to be associated with the pointer, that is address of the next element or the previous element. So there is an extra space required for the pointer. This is one more disadvantage of linked list. Not cache friendly. Okay. Since I do not have contiguous memory location, there is something called as locality of reference. This right now you will not understand. When you go for operating system in the 4th semester, you will understand this very thoroughly. Okay. Right now I'll not comment on this. So advantages of linked list, you have dynamic nature associated and very easy to insert and delete. But when it comes to accessing, when you want to search for an element, arrays play a better role than the linked list. Okay. So there are different types of linked lists that are available. I have basically 3 categories of linked list. One called the singly linked list, second called the doubly linked list, and third one linked list with the header node. Okay. The third one I'll be taking a bit later. Okay. Once you have understood these two, then understanding the third one will be much convenient. Okay. So let me just go ahead with what is the meaning of singly, what is the meaning of doubly, why we call singly, why we call doubly. Okay. So if I have the arrangement of elements in such a way that every element in the linked list knows who is their next Am I audible properly? Please comment, because there is a power loss.
Yes, ma'am, audible.
Yeah, thank you. So when I have when can I call it as a single list? Suppose I have something called as arrangement of elements in such a manner that every element knows exactly where my next element is available. Every element knows where exactly the next element, my next neighbor, is available. And when I talk about doubly linked list, every element knows where my next element as well as my previous element is available. It is both side linked doubly list. Every element at a point will know who is next to me, who is before me. In case of singly linked list, every element knows who is next to me but doesn't know who is before me. If you want to reach before that particular node, you have to scan in a random manner. That is a round robin algorithm. Okay, now you don't bother about it. So you just bother about what kind of element storage is available in the linked list. That kind of decides whether it is singly linked list or doubly linked list. Okay, you just imagine every now you just have to imagine right now. You just imagine that I am a node, I am an element being at fourth position. I know what is the address of fifth position element. I know what is the address of fifth position element, that is next to me. Okay, after me, who is available, that element's address, if I am knowing only about that, only in one direction, the flow of elements or the accessing of elements goes only in one direction, that is called a singly linked list. Imagine now I am at fourth position. Being at fourth position, I can go this way also, I can go this way also. Both directions are accessible. Means who is previous to me, I can reach to that. Who is after me, I can reach to that. In both directions, if I am able to move, that is called as doubly linked list. Okay, so I have a single linked list which talks about single direction movement. Doubly linked list talks about both directions movement. Okay, if you want to insert at any point in time, you just have to move in one direction to insert that element. Fine. That's why the linked list will not support what is called as random accessing, unlike the arrays. Very good point pointed out. Okay. Now, be it singly, be it doubly, whatever it is. Just 1 minute. Hello. Hello. Okay, be it singly linked list, be it a doubly linked list, I have two subcategories. What they are called as circular singly linked list or circular doubly linked list, or non-circular singly or non-circular doubly. What is the meaning of this? When can I call a linked list as singly? When can I call an array as circular? Can anybody comment on this? When can I call an array as circular, or when can I call a linked list as circular? Are you able to hear me properly? Please let me know. Yes, okay. Because many people have commented voice is breaking. Now audio is okay. Okay. You have commented when the first and last are connected, correct? When last element contains the address of the first element, very good. If last element has the address of the first element, all answers are correct. Whenever there is a linking or wrapping around of the linked list in such a manner that last element is reachable to the first element, that kind of linked list is called as circular linked list. Circular can be singly or circular can be doubly. It means what? If I can move from last node to last element to the first node only, but I cannot move from first to the last, then I call it a singly. when I have the accessibility in such a manner that last element reaches the first element and first element in turn reaches back the last element, that kind of list is called as doubly linked list, circular doubly linked list. Okay, I hope this is clear for you, or any doubt you have. Any doubt up to this point? If no doubts, I'll proceed. Can I proceed ahead? Okay. We cannot access from first to last element in single. Praveen, you will see this when I go ahead with this examples. Okay. Now, let me take one simple example and you have to comment on this. Now, any element when you are trying to insert that element, now first I will discuss about what is called a singly linked list. Okay, so with singly linked list I will be beginning this linked list. Now in a singly linked list, every element is associated as an entity. Okay, and that entity has two very important parts in it. I am repeating this point again. It has two very important parts in it. One is called as the information part and the other part called as the address of the next element that is residing beside the current element. Okay, so I will represent that by what is called as a node. I represent that by what is called as a node. Node looks like this. This whole node indicates one element. Okay, it has information part and it has an address part. Okay, I call this address part as the link part. So information part contains the element which has to be inserted. The element can be a simple integer, it can be a single character, it can be a floating point number, a double, it can be a string, it even can be a whole of structure. Okay, element can be anything. What this part is about? This part is the link part, which is nothing but the address of the next element, because as I'm talking about singly linked list here, every node, every element is represented as what is called as the basic building block of linked list called as node. And every node contains two very important parts, one called the element part and the other called the address part. The address part, I call it as link. So there are two parts in every node. One is the information part and the other called as link part. Now, if I will assume that any element that is getting inserted initially is called by what is called as a pointer called as first. Okay, a pointer by name first is associated with any element that is getting inserted initially. If the first ever element that is getting inserted is not pointing anywhere, what is the meaning of, what is the value that is contained in first? Imagine linked list doesn't contain any elements. So I'll just map this to the previous things that we have done. When I don't have any elements in the queue, where is front pointing, where is rear pointing? I mean to tell, when I have empty queue, I have initial values of front and rear. When I have empty stack, I have initial values of top. Similarly, when I have an empty linked list, what is the value contained in the first pointer? I told you, first points to the first ever element that is getting inserted. Okay, if I don't have any element in the linked list right now, what is the value of first? Can anybody try this? Okay, I don't want any specific or correct answer. You may try this. Okay, I have two answers, both have been written as null. Why it has to be null? Among both of you, can anybody comment on this? Why it has to be null? Why it cannot be 0? Yes, can you comment? Pranav? Yogesh? Praveen? To indicate empty list, why it cannot be -1? Yes, Suman, you have raised the hand. Suman, can you comment? Okay, Praveen has commented if it is a character, then null. If integer, then 0. Garbage value will be there according to Srinivas. Okay, let me just give the answer for this. What is the data type of this node? Before I begin, what is the data type of this node? Can I call this node as integer? Can I call this node as character? Can I call this node as string? Can I call this as a float? What is the data type of this node that I have drawn? If you can understand this, then you can comment. Okay, it's of type struct. It's of type struct. It means what? It is a user defined data type. It's a user defined data type. And when you talk about user defined data type, this node, as I'm speaking about, this node before getting created, I have to call what is called as a memory allocation algorithm or memory allocation function like malloc, realloc or calloc. Okay, when I call memory allocation algorithms, either the memory allocation algorithms return the address of first byte of the allocated memory locations, or it will return a null. I'll repeat. When you call, whenever you want to have a new node getting created, new node of has to be of type struct, and whenever you are creating a new node, that new node has to be allocated with the required amount of memory locations, and that required amount of memory locations is made available by what is called as malloc function. When you call a malloc function, if the malloc function creates a new node or allocates the memory locations, then it will give you the address of the first byte among the allocated bytes. But if not allocated, it returns a null because it is talking about address. It is not talking about any other thing. Since it is address mattering, null is the initial value of the first. If the linked list is empty, first has to be null. First has to be null. So whenever you want to create a node, you have to have a structure involved. That structure needs to be passed to what is called as a malloc function, which allocates memory location for the whole node. What is the content of the whole node? The whole node contains an element and the address. Then what is this address talking about? Address is talking about what is this address has to talk about. See, now I have a node. I have inserted 10 in it. Okay, initially this is the only node available. Then I will assume that address contains null. It means what? 10 is the only element available in the linked list. Now if I try to insert one more element, this null gets replaced with the address of one more node. Okay, this one more node again contains what? Information part and the link part. This one more node has to be linked with one more node, that is the third element, and third element also is represented by a node which again contains information part and the address part. This continues. So this part, the address part or the link part, must be an address of the node itself. What is it? It is the address of the node itself. But is it the same node? No. It is the address of the node with a different element. So what is this part containing? This part contains again the address of the next node. Address of the next node, when I am talking about, it is again the data type struct node. Are you getting this or not? Please let me know right now. Otherwise, I will explain it again for you. Please let me know from your end. I want to have comment from each one of you. I'm waiting for your comments. Have you understood this explanation or not? Okay, once again I have to explain. So let me just clear the screen for you and let me just repeat the things. Okay, I'll open it for you. Now, you just imagine a node in any linked list will have two important parts. I'm talking this about single linked list right now. Don't bother about any other types of linked list. A singly linked list will have elements in such a manner that elements are arranged as, each element is arranged as part of an entity called as a node. Okay, and the node contains two parts in it. Every node contains two parts in it. One is the actual information, the element getting stored, and other is the link part, that is, it is having the address of another node. It's having the address of another node. Okay, so if I want to have a node represented, I will have a node in this manner. There is an element, say 10. And if this is the only element in the linked list, this is currently the only element in the linked list, this is pointed by the pointer first. If this is the only one element available in the linked list, then what should be the address part? Address part should be a null because it is not having any address of any other node. If this is not the case, if there are more than one elements in the linked list, okay, every element is considered as a node, not as a single element or a simple element. Now imagine I have a linked list containing 3 elements. So 10 is the first element. Then this part, the link part, must have the address of what? Address of the next node. Address of the next node. So this part is nothing but address of the next node. So can I draw this like this? There is a linking between this node to the next node, and the next node, again, it contains what? Two parts. The information part, say 20, and address of the next node. Address of the next node. So I will show that by an arrow. I'll show that by an arrow. I call it as a link. Link from current node to the next node. When I have an arrow pointing to the next node, the address of this node is getting stored as part of this. So the link part of every node is nothing but address of another node. Can I call it as link to a node itself? Please comment. Can I call this as a link to another node? It means a link to node itself. What is the data type of this? If I imagine a node can be called as struct node, what is the data type of this part? What is the data type of this part? It is also struct node. Okay, so what is the data type of this? What is the data type of this? The data type of the link part of every node is struct node star. I will repeat again. I'll repeat again. I may have to repeat it 100 times, but you have to understand it very carefully. Okay, let me draw it again. So I have the first node, say 10. Okay, now I have one more independent node and I want to link this to the first node. So what is the way out? The link part of the first node has to be assigned with the address of this node. Has to be assigned with the address of this node. How can I do that? And what is the data type of this node? What is the data type of this node? It is struct node. Okay, it is struct node. What is the data type of this node? It is also struct node. Now I want to have a pointer pointing to this. I want to have the pointer pointing to this. So what is the data type of this part of every node? It is struct node star because it's a pointer. So the node, every node in a linked list will have two parts in it. One is the info part and the second one called as struct node star. Why it has to be called as struct node star? Because it is nothing but the address of another node, and another node's data type is struct node. When I talk about address, I talk about pointer. So what is the data type of the second part of every node of a linked list? It is nothing but struct node star. I call it as struct node star link. Any doubt at this point? If you have not understood this, I will explain it again for you. Please let me know from your end. So what is the data type of first part? It is the data type of the element which you are inserting. Be it int, be it char, be it character array, be it a file itself, whatever it is. That data type falls here. What is the data type of the second part? It is nothing but struct node star link. Yes, guys, have you understood this or not? I'm waiting for your comments. Only Suman has commented yes. What about others? I just want almost everybody commenting yes, understood. Okay, only then I can proceed ahead. Otherwise, no, because this is a most important part of understanding. Okay, thank you all. Now, can you create a structure by name node in the programmatic manner? Now, if I want to write in a programming manner, creation of the node. Node is a user defined data type. Okay, creation of a node. Now, how can I write? Every node has two parts in it. Okay, I'll call it as struct node, opening bracket. Imagine that I have an information part of type info int. I'll create int info. What should be the second member of this structure? Can anybody comment? Based on the explanation that I have done till now, can anybody comment what should be the second member of the structure? Correct. Struct node star link. This constitutes a node of a linked list which is called a singly linked list. Have you understood this much? This is a basic building block of a linked list. If you have understood this, I will be more than happy for this class. Okay. I will comment before I proceed. This kind of referring to itself. See, a structure pointing to itself. A structure pointing to itself. This kind of structure is called as self-referential structure. Okay, it is called as self-referential structure, where a structure pointing to itself. There is a member of a structure which has a pointer to a node which is of same category. Such a kind of structure is called as self-referential structure. Okay. I hope these things are clear to you.
Excuse me, ma'am.
Yep. Go ahead.
Ma'am, can't we implement the same thing using array of structures with dynamic allocation, ma'am, of memory?
Definitely you can. Definitely, Praveen. But it has its own complexity.
Yes, ma'am. But there we can't link the address, ma'am. I don't.
Nahi, using
That part.
arrays also you can implement linked list. I'll show you that when time comes.
Okay, ma'am. Thank
Okay.
you.
But it has its
Yes.
own complexity. It's not as easy as a pointer. Okay.
Okay.
Yeah.
Yes, ma'am.
Yeah.
Thank you.
So with this introduction, I think I'm left out with only 1 minute. Okay. With this introduction, we will be ending the session for today. The programming things, we can take it on Wednesday, I think so. Please comment. Or you want me to continue today's class? Definitely you will tell no. Okay, quickly. Shall we end the session for today or you want me to have one more session? Jaldi bolo. Continue. Okay. Then if you want, then continue. So nice, Praveen. Okay. So how about others? I'm left out with only 1 minute. Okay. We will take up one example on it and then we will stop. So please join back after 5 minutes. Thank you all. Okay, join back after 5 minutes.